All right, so this is a slide from last week, right? And you were given a triangle here, right? Now I'm just going to change up the values a little bit, right? The values that I'm going to put for the triangle is not going to suit the graph, right? So we have 3 points here. Point A, I'm going to call this one B, and I'm going to call this one C. Let's just assume point B was 5, 3. Point A was 5, let's call it 10. And point C was, let's call it 8, 8. Let's say in the exam, they had asked you to rotate this triangle by 90 degrees anti-clockwise. In case you can't remember, anti-clockwise is this way, right? The opposite the direction of a clock moves. If you look back in your notes, you will see to do an anti-clockwise rotation using the matrix C method, you would have to memorize this matrix. Now, for the anti-clockwise, look where the minus sign is. The minus sign is by the top sine theta. I want you all to calculate the new points of A, B, and C if it is rotated by 90 degrees anti-clockwise. And I want you to send the answer on the chat. So that's your revision question to start here today. You are rotating A, B, C by 90 degrees anti-clockwise using a matrix C method. Obviously, when you rotate it, you will get 3 new points, A prime, B prime, and C prime. I want you to send the answers for A prime, B prime, and C prime. Giving you 5 minutes and good luck. So I'm hoping that everyone remembered if the examiner asks you to rotate it by 90 degrees, and of course, in most cases, he will give you the angle. Well, he has to give you the angle if he wants you to rotate it by a certain angle. And of course, you choose the correct matrix. It's very easy to mix up the anti-clockwise matrix with the regular boring clockwise matrix. Both of them have the minus sign in a different spot. And of course, if the minus sign changes position in the formula, obviously it changes the whole question. So what you're supposed to do is go to the formula and replace all the thetas with the angle the examiner gave you. In today's question, the angle is what? 90 degrees. So you're supposed to replace this with 90, this with 90, this with 90, right? And it's degrees, right? So you can put a small little 0 on top, the degree sign. And all you want to do, if you type in cosine 90 on your calculator, you will get 0. If you type in minus sine 90 on the calculator straight and press equal, you will get minus 1. If you press sine 90, you will just get positive 1. And cosine 90, we got 0. How much people got the correct matrix at least? 0, minus 1, 1, 0. Great. Take it from there. Take it from there. So we're going to take point A. Now, right now, point A is what? 5, 10, right? The X comes first, the Y comes second. But when it's time to multiply it, you put the X value on top and the 10 underneath. And of course, if you take this matrix and multiply by point A, you will get A prime. That's the position where A will move to. Anybody got this? Minus 10, positive 5? Anybody can agree with that answer? Like I said, at this point, I'm not going to go through how to multiply matrices. We've passed that point in class completely. And everyone by now, if you did the homework and you were really following up in class and taking it seriously, you would be able to multiply a matrix smooth without any issues at this point. Great. So we just have to do the same thing for point B. If we take, I'll use a different color here. Point B is how much? 5, 3. This is X and this is Y. So it's 5, 3. When you multiply it out, you will get minus 3, 5. Well, when the top value is obviously the new X value and the underneath value is the new Y value. And the same thing for point C. Point C is how much? 8, 8, 8, 8. You're going to get -8 and +8 underneath. And of course, if you plot these three new points, if you plot A prime, B prime, and C prime, and you connect the points, it will look like the entire triangle got rotated by 90 degrees anti-clockwise, right? So a lot of people sent the answers way, way, way before, right? But I'm going to give you 1 minute to finish up your calculations and make sure that you get my answers, right? So look for any errors. And then I want to discuss something else about this particular formula, right? So you have 1 minute. This formula, well, all rotation formulas, right? All rotation formulas. Well, there's only two rotation formulas. It's either clockwise or anti-clockwise. All of them assume that the center of rotation is the origin. So let me just clear the screen there. So what does that mean? Well, this point here, we all know where the origin is, right? So let's put a little arrow here. This is the origin. That assumes, think about it like this. Pretend that you're going to connect each point here. Like this was point A, I believe this was point B, and this one was point C. Pretend that you take a piece of rope and you connect it to the origin. And then for point B, you do the same thing. You take point B and connect it to the origin. And then you take point C, you tie a rope to the origin as well. And you're keeping the rope tense. You're not letting the rope get slack. And you rotate it anti-clockwise. But the point is, all the rope is tied to the origin. So it begins to spin or rotate about the origin. In other words, this formula only assumes that it's tied to the origin. If in the exam, they tell you that it's not happening about the origin, like the center of rotation is not the origin. For example, let's say we tie the rope somewhere else. Let's say they decide to tie the rope here. I'm going to call this point R, and the coordinates of this point is -3, +3. If they tell you to rotate it about the point -3, +3, that assumes that the rope is being tied to that point. Will you be able to use the rotation formulas in a case like that? Would you be able to use cosine, minus sine, sine, and cosine? The answer is 100% no. So you're probably asking, is there a formula for when the center of rotation is not the origin? Yeah, well, there is a method you can use, a matrix C method, but it's not on the syllabus anymore, as far as I know. Anytime the center of rotation is not the origin, you have to use a drawing method to get it out. You can't use the matrix C anymore. So in order to do this particular question, where the center of rotation is not the origin, you'll need to get a ruler and a pencil and actually draw or do some calculations with your ruler and pencil, like a drawing calculation to actually rotate it. And of course, I'm going to show you how to do that today eventually. So whenever you're doing rotation questions, the point I'm trying to make is that there's two methods you could use. The matrix C method, or a last resort, you could use the drawing method. Right? But anyway, let's continue the story. I think you all saw this slide from last week. Right? Oh, by the way, anybody remembers the name of the lady in this one? Well, what's her name? And she's supposed to go marry this wealthy baron because her parents kicked her out of her house because they were having another child. It's Jenny. Right. And I think you all saw this slide. So she went to meet the Baron. I was unable to do the voices, so you just have to read this one. But you already know what's going to happen. The wealthy Baron tells Jenny, who usually raps and makes everything rhyme, ask her to marry me. She says no. He says, marry me, please. She responds, I would rather die of some disease, which rhymes. And then he says, I'm telling everyone you're a witch. Oh man, I knew you always were a snitch. All right, but you are, and she could talk to rats also, right? But you always see what happens to Jenny eventually. Suppose you want to do this particular question, right? And you want to rotate this triangle by 90 degrees, right? Anti-clockwise. And the examiner tells, I'm telling you that the center of rotation is the origin. But I don't want you to use a matrix C method, right? I want you to use a drawing method. So how would you do this question? But first of all, you have to get a ruler and a pencil. Here's A, this is B, and this is C. So here's what you would do. If the center of rotation is the origin, you're going to take your ruler and connect point A using a ruler to the origin. And what you're going to do is measure the length of that line. So let's see the animation for it, right? Well, we're starting with point B. I guess it doesn't matter. Well, tell you what, let's call this point A. Yes, we'll make sure I did properly. Right. Right. Okay, 1 second, guys. I just have the letters out of order. So just for today's one, we're going to call this point A, this one point B, and this one point C. Right? There's no need to draw anything here today. You just follow it. So we're going to take point A and connect it to the origin. So you all saw a line appear here. What you're going to do is take your ruler and measure the exact length of that line. Remember, the examiner told you the center of rotation is the origin. Let's say that we measure the length of this line and we got exactly 5.5 centimeters. That'll be real exact. What you are going to do is use your protractor. You all remember what a protractor is? That's this. And a protractor allows you to measure what? An angle. You are going to have to measure exactly 90 degrees and draw a line from the origin at 90 degrees to the line you just drew. Anybody wants to tell me what would be the length of the perpendicular line, the line at 90 degrees? Let's take a guess. It's not even a trick question. Well, what do you think the length of that line is going to be? It's going to be the same exact length, right? 5.5. So if the length of this line is 5.5 at 90 degrees, you measure real good, and you measure the length of that line at also 90 degrees. So if this is point A, if you do the calculation properly, A prime will end up here. But it only works if you do two things super accurately. You measure the length of the line exact, and you get the angle to be 90 degrees exact using your protractor. Now, I have to make the assumption here, everyone here can use a protractor. And guess what you do? You do the same thing for all the points. You're going to do the same thing for point B. Take point B, connect it to the origin. You always see that red line there. I take my ruler. I measure it exact. Let's say the length of that line is 8 centimeters. From this 8 centimeters, I use my protractor and measure what? A line at 90 degrees. Look at the red dashed line. The two dashed lines, the two red dashed lines are exactly 90 degrees. And of course, the length of this line would also be 8 centimeters. And I do the same thing for point C. I take point C, connect it to the center of rotation, which happens to be the origin in this question. I measure the length of that blue line. Let's say the length of that blue line is 10.3 centimeters. You have to be super exact. You're going to have to draw a line at 90 degrees to that blue line using your protractor. So it's going to look something like that. The new blue line is going to also be 10.3 centimeters. So B prime is going to end up here, and C prime is going to end up here. And if you take your ruler and connect all 3 points, all 3 new points, it will look like the triangle got rotated by 90 degrees anti-clockwise. Now, which one do you think is going to be easier? The drawing method or the matrix C method? Which one do you think is going to be easier? And of course, it's going to have less mistakes in that method. The matrix C method, right? That's going to be the easier one, because I could see students not drawing the straight line properly, measuring it, the length wrong, and then not measuring that 90 degrees perfectly. But the only time you have the option of using what? The matrix C method is when the center of origin, when the center of rotation is the origin. Okay? So obviously I'm going to show you a method, a question just now. I know I said that before. I'm going to show you a question where the center of rotation is not the origin. And if you look at all of these lines, like the blue lines, doesn't it look like each line got rotated by 90 degrees? Isn't that 90 degrees there? You can do the same thing for the red line. If you draw an arrow, all the lines are going to look like they got rotated 90 degrees anti-clockwise. So if anybody wants to screenshot this, feel free. Right? Take a 10 seconds and we're going to move on. Move on. All right, so let's see what's happening with Jenny here. So remember, the Baron, well, because Jenny didn't want to marry him, accused her of being a witch. So he spread a really bad rumor about her. And of course, it's medieval times, so people get very, very, very suspicious and frightened, and they drag poor Jenny to the gallows. She's accused of being a witch. So the bitter nobleman convinced the town people that Jenny was a witch. She was dragged to the outskirts of the town and hanged. The villagers left thinking that she was dead. However, they didn't know the noose wasn't tied properly, and so she was still barely alive. So anyway, let's hear Jenny's so-called last words. But she thought she was going to die. So let's get the music going. All right.
I'm gonna die. Didn't even get a chance to testify. Gonna see God in a while.
All right, so that's Jenny's rap on the gallows there. And of course, these are the townspeople here. Let's hear it one more time.
I'm gonna die. Didn't even get a chance to testify. Gonna see God in a while.
Well, that's a pretty good rap, in my opinion. All right. But obviously, Jenny is going to survive, right? Because, you know, the noose wasn't tied properly, and the town people got bored and left. I guess they see hangings every day. All right. Could you all do this question for me? Rotate, this is actually a trick question in the exam, right? Something that's supposed to confuse you. Let me just write back the coordinates here properly. So the examiner comes and says, hey, I want you to rotate this triangle by 180 degrees using the matrix C method, right? Now we're going to assume that the center, I know I left out the words, but the examiner is supposed to make it very, very clear that the center of rotation is the origin. So I'm just putting it in. Who can tell me what other piece of information is missing? The examiner now asks you to rotate it. What other piece of information do you think is missing? Right. Some people figured it out. He needs to tell you whether it's clockwise or anti-clockwise. However, when it's 180 degrees, the examiner will not tell you whether it's clockwise or anti-clockwise. And here's why. Let's say I have a line, right? Let me draw a line here, right? Or let's draw a north, east, west, and south, right? North, east, west, and south. So you have some sense of direction. Let's say that you have an arrow, a pink arrow facing north. Remember, 180 degrees is half a circle. If I tell this pink line to rotate 180 degrees, if I tell him to rotate 180 degrees clockwise, won't he end up by the south? Pretend this rotating like the clock of the hand of a clock, right? Won't it end up south? But if I ask the same pink line to rotate 180 degrees anti-clockwise, won't it also end up in south? So whenever you're rotating 180 degrees, it does not matter if you rotate clockwise or anti-clockwise, but that only works for 180 degrees. So whenever the examiner asks you to rotate something by 180 degrees, it does not matter if you choose the anti-clockwise matrix or if you use the clockwise matrix. You will get the same answer at the end of the day. All right? So to keep things simple, right? I'm not going to ask you to multiply all the points by the matrix, but could you all at least get the matrix for me? Go and replace, well, I'm choosing the anti-clockwise rotation formula. Once again, it doesn't matter, even if I choose the clockwise one. And I want you to go and replace all the thetas with how much? 180 degrees. And send the matrix for me. Like, all I'm asking you to do is get the 4 values in the matrix that will allow me to rotate that triangle by 180 degrees while assuming the center of rotation is the origin. Right? So send the 4 values for me. Well, I have more space underneath here, but you had to go and replace all the thetas with the angle they gave you, right? So you're supposed to say cosine 180 minus sine 180, sine 180, and cosine 180, right? Now, if you're typing all of this on the calculator properly, this will give you -1, this one will give you 0, this one will give you 0 again, and this one will be -1. So the matrix will be -1, 0, 0, -1. And all you would have to do is take this matrix and multiply by point A, then point B, and then point C, and that will give you A prime, B prime, and C prime. And you plot it on the graph, and you do what? Plot, well, connect all the points, and it will look like the triangle got rotated by 180 degrees. Now, like I said, I'm not going to ask you to multiply all the points. I think we pretty much can handle that in class by now, right? All right, so let's move on. Let's move on. And once again, this formula assumes the center of rotation is the origin. Let's go. Well, I'm not too sure. I repeated this by mistake. All right. So let's see what happens to Jenny here. All the townspeople have left except for her rat friend. Remember, she can speak to rats. Right? Remember, in the afterlife, right, the most important thing to Jenny was a piece of cheese. And we're supposed to try to figure out why that piece of cheese was so important to her when she was alive. But Jenny always had cheese on her. With her last breath, she told the mouse he could have the cheese in her pocket if he nibbled the ropes to set her free. Right? So the cheese technically saved her life. Right? And of course, the rat is a smart rat, right? Right? So, made her write up a contract first. I don't know how she did that with her hands tied, but yeah, we'll let that slide. All right. Right. So here we have a new question where we have a triangle, right? Let me just put the points here, right? I'll just call here A, I'll just call here B, and I'll just call here C. And the examiner wants you to rotate this triangle by 270 degrees clockwise using a drawing method. But look at this question if you keep reading on. The center of rotation is not the origin. The center of origin is 1, 4, which is 1 on the X and 4 on the Y. Right, I'll put it back here, 1, 4. The examiner is kind of being nice here. He's telling you to use a drawing method. Could we use the matrix method in any case? No, right? Because if the center of rotation is not the origin, we have no choice but to use a drawing method in any case, right? So guess what you all will do in a question like this? You're going to do the same thing, huh? You are going to take point A and connect it to what? R. So using your ruler. So watch here carefully. But let me change up the point. Just I'm going to see if I get the points in correct order here. Right. 1 second. That's not. Oh, this is point A, this is point B, and this is point C. So all we're going to do is take point A and connect it to the center of rotation here, right? And we're going to use our ruler and measure the exact length of that line. And then do what? Use our protractor and measure how much degrees? 270 degrees clockwise. So let me show you how that's going to look, right? If we do that, point A prime will end up down here. Remember, the length of the two red lines are what? The same length. But I know some of you all are saying the angle is supposed to be 270 degrees clockwise. Doesn't this angle look like 90 degrees, not 270 degrees? But think about it. If I have a circle, isn't a circle 360 degrees? So if this piece here is 90 degrees, won't the piece behind it be how much degrees? 270. Everybody okay with that? That a full circle is what? 270, 360. So if one piece is 90, the remaining piece is 270. So whenever somebody asks you to rotate something 270 degrees clockwise, you will get the same outcome if you spin 90 degrees anti-clockwise. So this angle here is 90 degrees anti-clockwise, but that's the same thing as 270 degrees clockwise. Okay? It makes it easier now because it's easier to measure 90 degrees on a protractor rather than what? 270. And guess what, guys? We're going to do the same exact things for all the points. We're going to take point B now, connect it to R, measure the length, and go 90 degrees downwards. So let's see that in action. Take point B. Look at it properly. Huh? Look at the blue line going from B all the way to R. I know it kind of overlaps the red line. Sometimes that happens in the exam, so it takes a good eye. Measure the length of that blue line. Use your protractor. Measure 90 degrees. Make sure the two blue lines have the same exact length, right? So B prime will end up somewhere down here. And you do the same thing for point C. Take point C, connect it to R, measure the length of that green line. From the green line, measure 90 degrees with your protractor. Make sure the length of the two green lines are exactly the same and exactly 90 degrees apart. And that will give you C prime. And then you connect all the points. And it will look like your triangle got rotated 270 degrees clockwise, which is the same exact thing as rotating it 90 degrees anti-clockwise. Everybody okay with that one? You just connected it to the center of rotation, which the examiner will specify. And I think you all see the pattern here, right? You can screenshot this if you need to, right? You don't need to draw this from scratch. It would just take too much time. I just need to make sure you all understand the concept. All right, so what do you think happened to Jenny afterwards, right? After she was rescued by the rat, okay? Let's see her ending story. Jenny fled France forever and sailed to Spain. By using a very clever disguise, no one was ever able to find or recognize her. She spent the rest of her life working in a cheese factory with her best friend, the mouse. And this is Jenny and her disguise. Very clever, in fact. No one would ever know that was Jenny. And of course, her best friend, the rat, is demanding his cheese. All right. All right, so that's the end of Jenny's story, right? All right, so how much of you all in school know how to divide a line in two using your compass? It's usually a Form 2 topic. Right. So in order to do this, you need a compass, right? So I can have a diagram there, right? Everyone should know what a compass is by now, a drawing compass, right? You get it in a geometry pan. And I have two ways of showing you this, right? Let me just do it manually first. Let's say that you have a line, right? The line starts at A and the line ends at B. Let's say that you want to divide that line in half. Now, the easiest way to divide a line in half is just to use a ruler, measure the length of a line, and then divide the length by 2, right? That's the easiest way to split a line in half. But sometimes you need to use your protractor. So what you would do, I'm going to call the P as the point of the protractor. Well, sorry, both P, point, and pencil start with P. All right, so here's what you're going to do. You're going to put the point of the protractor at point A, and you're going to extend it to more than half the line, right? So you extend it from more than half the line, and you're going to draw kind of half a circle from point A. And then without changing the distance from the pencil to the point, you do the same thing at point B. You put the point of the protractor at point B, and you scribe another kind of half a circle. Both arcs, both the pink and green arc, will meet at 2 points. That's going to call this point 1, and I'm going to call this point 2. If you use your ruler and connect point 1 to point 2, this blue line will cut line AB into 2 equal pieces. In other words, from here to here would be the same length as from here to point B. And another good thing about this method, the blue line and the pink line will be at 90 degrees. Right? So that blue line not only slices AB into 2 equal pieces, but it slices it at exactly 90 degrees. Anytime a line slices another line at exactly 90 degrees and exactly in half, you call that line a perpendicular. Well, perpendicular means 90 degrees bisector. To bisect something means to cut it in half. Everyone, let's quickly draw this diagram for me, and then I have a video to show you where you see the animation will do exactly what I just suggested here, but better than how I did it, right? So everyone draw this back for me and let me know when you are finished, and we'll watch the video after. Now, hopefully it works. Oh, well, before we look at the animation, so Jenny thanks you for listening to her story. And of course, she has some information to share. The Miller brothers are planning to kidnap the Queen's nephew today at 5 p.m. All right. Anyway, let's get to this. Right, so pay attention. It has no sound. So what's going to happen? We're going to try to replicate that diagram. It's a bit slow, but we're going to try to divide the line AB into two equal pieces. Right, so that's the line we want to divide. Right, so that's the 2 points where the 2 arcs intersect. And we're going to connect point P to point Q. And that new line is the perpendicular bisector. That black line is the perpendicular bisector. All right, so, right. Like I said, I'm hoping you all did that in what? Form 2 or Form 3 or somewhere around there. All right, so let's just go back here quickly. I just want to see something. That's not. I want to pause it here. That's not right. So just to answer a question. Oops. And when you have it online here, just on, guys. 1 second. Oh, okay, some technical difficulties here. Right. So remember, you just put the compass at the beginning of the line and at the end of the line, and you scribe both arcs from that pointer, and it's where the 2 arcs meet. You connect that point. And when you draw this new black line, it will automatically slice the red line in the center, and it will always be at 90 degrees. Right now, if you all are not good at construction, like I have a video after, a full video on construction. I could probably show you guys one time before we move on, right? In case I forget after class. By now, everyone should be able to access what? The school website, right? I've been talking about it for what? 3 weeks straight. So when you go to the school website, right? You all know you could find the recordings under the summer classes 2024. But let's say there's a maths topic that your teacher didn't do good in school, or teacher didn't do it at all, or whatever, right? Or you just didn't understand it. All you have to do is go in the maths classroom, click on it, and if you scroll down, right, you can skip all of this. Let's scroll down in the maths classroom, and you will see maths syllabus topics. I have every single topic labeled and available for you guys for free for the summer, right? So for the summer, make use of it. So the name of that topic, I believe it's construction. Let's look for construction. Let's keep going down until we see construction, right? It's a lot of topics, right? Similar triangle. Oh, look at them. That's lesson 29. Make a note of it. Construction of angles. This has every single thing you need to be able to do with a compass. how to construct 90 degrees, 180 degrees, how to bisect a line, right? As far as I know, the math classroom does not have a password on it. If it does, I will remove it today. But as far as I know, I've made it free for the entire summer without a password attached to it. So for those who are truly interested in learning the topic, feel free and make full use of it, right? Great. Right? So let's move on. Now remember, these things are, right, guys, you gotta be understanding with me, right? Remember, this is only available for free for the summer. Remember, I have a living to make as well, right? I have a family to feed, right? So for the summer, everything is free, right? But as soon as the summer is finished, obviously the passwords are going to go back on. Everything is going to get locked behind a password, and it will only be made available to, to those who join the lessons, the paid classes in September. And I think that's very fair, right? So I think, right, unless you all want to see me living on the streets, right? So, all right. Let's move on. Which part did we reach? All right, so we reach over here. Right, so all the information about the paid classes, I will send it to your parents on the chat. I will have it ready sometime this week, and I will send it to everybody, right? Timetable and costing. So anyway, let's move on to the new ghost. This new ghost, her most prized possession is this strange looking what? Pendant. It's a strange looking pendant. It's very important to her. But why? Why is it important to her? Her name is what? You wait a few minutes and you see a ghost why that tells me while wandering amongst the tombs. In her hand is a very, very strange pendant. She seems to be talking to herself. It's not a piece of pizza, guys. It's a pendant. She keeps mumbling to herself. I'm sorry, forgive me. This wasn't my fault. I did not know what I was doing. What do you think she did wrong? Anybody want to take a guess? When she was alive, what wrong thing you think she did? Why does she keep begging for forgiveness? Let's hear your theories, guys. I always like to hear the crazy theory. All right, so here's what we're going. Oh, this is one you're gonna use the imagination, right? Everything from this point on, when the majority of class is to be able to bisect a line. So for the rest of class, well, I'm hoping so, you all will be given a line, right? So let me just say the line is AB. The whole point, you're gonna have to be able to do what? Bisect the line using your compass and then drawing what? A perpendicular bisector. Now pay attention, all right? This one could be complicated, right? This is probably the most complicated part of transformations. These are what I call a reverse question or a sort of backwards question. The examiner will give you two triangles, right? So let's call this point A, this A prime. Let's call this point B and this point B prime, and this point C and this point C prime. It looks like this triangle has already been rotated. So A, B, and C was rotated by a certain amount of degrees. We don't know how much degrees it was rotated by, and it was rotated about a certain point. We do not know the point. So guess what the aim of the question is, right? We have to find out where the center of rotation is and how much degrees it was rotated by. Most students dislike this question. To me, this is one of and not harder. It's just to be able to get everything to fit on the graph paper is the problem. So how do we go about finding the center of rotation and how much degrees it was rotated by? Step one, you connect two similar points. The first thing you want to do is take any point, and I started with point B. It doesn't matter which point you started with. And you take point B and connect it to B prime. It started off as B, and after it was rotated, it ended up at B prime. You see that red line? Guess what you are going to do? You are going to use your compass and bisect it. So that's right. You have to take your compass, put it at point B, scribe an arc on the graph paper, then go to B prime, scribe another arc, and draw in the perpendicular bisector. So let's see how that is going to look. Everybody agrees it will look something like this. I kind of skip forward. When I put the compass at B prime, I scribe the first arc, that's this. And then I went to B and scribe the other arc. And now I'm going to draw in the perpendicular bisector. So look carefully. So we're drawing that after. And we're going to do the same thing for point C. Draw a line from C to C prime. And you are going to bisect that blue line. So when you use your compass, you will get this here. And then you do this. Well, you only have to do it twice, by the way, right? Just 1 second. You only have to bisect 2 lines. You do not have to do it for all 3. You could do it for all 3, but it's not necessary. So what we're going to do now, we're going to draw the perpendicular bisector for the red line, and then we're going to draw the perpendicular bisector for the blue line. When we draw both perpendicular bisectors, both of them will meet at a certain point. Wherever the two of them meet, in this case here, it's meeting at -4, -1. This here is the center of rotation. Do you all think you all can handle that in the exam? You have to have a really good compass, one that doesn't shift. You have to make sure the screw in it very, very tight. In other words, you are just connecting 2 similar points and bisecting it. And the 2 bisecting lines, the perpendicular bisectors, will meet at a certain point. Okay? So, quick question. We just found out the perpendicular bisector. How do we figure out how much degrees it was rotated by? To figure out how much degrees it was rotated by is very easy. Just take any point. Let's start with point C. Connect it to the center of rotation. And when it hit the center of rotation, let it bounce back to its rotated counterpart. So you connect C to C prime through the center of rotation. How much does this angle look like between the 2 green lines? Well, what does the angle look like between the 2 green lines? But is it 90 degrees clockwise or anti-clockwise? You will have to state that for the examiner. Is it clockwise or anti-clockwise? Right, it's anti-clockwise. Okay? Do me a favor. Take down the procedure for me. Write down the procedure on how to find the center of rotation. I broke it down in 4 steps for you guys. And then afterwards, if you want to screenshot the diagram, you can. But I want you to physically write the notes. I don't want you to screenshot the notes. Let me know when you are finished. Right. So in this question here, right, I want you all to practice this one, right? I'm gonna give you the coordinates, right? When class is not finished, right? But I just want to give you a practice question. Let me just give you 3 points here. This here is -6 positive 4, right? A prime is how much? 4 minus 4, right? Here is B -2 positive 2. 1 second here. This is the point 60. And then we have point C, -1 4. I want you all to take down the coordinates of A, B, and C, and take down the coordinates of what? A prime, B prime, and C prime. And when you go home, well, not go home, when class is finished, I want you to draw this triangle. This is the original triangle on graph paper, and draw this one on the same graph paper. And I want you all to find the center of rotation for me. So that's your homework question. And next week, which is our last maths class, I want you all to come back with the answer for me. I want you all to tell me what is the center of rotation, because this is something you physically need to practice now. Watching me do it explains it a little bit, but when it's your turn to do it, it has been much, much, much harder. Let me know when you finish taking down the homework. You don't have to draw the diagram today. Once you have the coordinates of A, B, and C, and A prime, B prime, and C prime, you could draw it neatly on graph paper after, and then do the question with your compass, right? Let me know when you finish taking down the points. And of course, you need to provide that answer next week for me. All right, so let's check her story here. The date was 1840. Oh, her name is Joanne, right? So I didn't put her name at the beginning. The date was 1845 when Joanne and her husband were given a job to map out a remote part of Romania, when one night the entire expedition was attacked by a strange wolf. All right, we think we know where this is going already. Everyone died except for Joanne. She was severely, damaged, mauled, and left amongst the trees. That's the wolf there. Scary looking, creepy wolf. All right, so we'll see what's going on with her just now. All right. So we're gonna do something, a special type of transformations now. It's called a translation. It's very easy to mix up the word transformations. Remember what a transformation is. A transformation is when you take a shape and you alter it, like rotate it, make it bigger, make it smaller. A translation, right, is a special type of transformation, right? It's a special type. It's a sliding type. When you try to slide a shape. Now, when you slide a shape from one point to the next point, will the orientation change? Will it change or not? Like, in other words, would the shape be facing the same direction if we slide it from one point to our next point? What do you all think? It will remain the same direction, right? Like if you have a person like this, right? And this is his nose and this is eye, right? Pretend you know what it is like when you take your mouse and drag it from one point to our next point on your screen. So let's see this man here, right? You click on him and you drag him to a different point on the screen. When you drag him to a different point on the screen, his nose will be facing the same exact what? Direction. So in a translation, right, You're not rotating the person to make him upside down. You're not, his nose is not going to end up facing the other way. It's basically a drag and drop. When you drag an image on the screen to a different point on the screen. But the image will always be facing the same exact direction. Okay? Great. So I want you to take down every, let me just explain what's going on here. When you're dragging an image, right? You can either drag it horizontal or you can drag it what? Vertical. Whenever you're doing a translation, you will always have two values, a value on top and a value underneath. The top value, right, is the horizontal motion. The underneath value is the vertical motion. Hence, I use H and V. The top value will always be horizontal. If you are dragging something to the right, the top value will be positive. If you're dragging something to the left, the top value will be negative. If you're dragging something up, the underneath value will be positive. If you're dragging something downwards, the underneath value will be what? Negative. It's kind of common sense. When you move to the left, so anytime you move to the right or up, it's positive. If you're moving to the left or down, those are negative values. Don't worry, you need to see it in action, right? And translations, it has nothing to do with multiplication. Remember when we were doing rotations and reflection on X and Y axis, you had to multiply the matrices. Translations only deal with addition or subtraction. In other words, the translations is the easy part. Okay? Take down everything on the screen. Don't worry. You need to see an example with this for this to make 100% sense. Okay? Let me know when you are finished. All right, so here's Joanne here. So she spent a few days in the woods slowly recovering. As soon as she had enough energy, she buried her husband and slowly tried to find her way back to civilization when she found a cabin. So that's a little cabin in the background there. She could smell food being cooked and heard laughter of a happy family. With hopes of being saved, she began to walk towards the cabin, when suddenly she began to feel funny as the moon shined on her. What do you all think is going to happen here at full moon? The full moon comes into effect. And Joanne turns into a werewolf. All right. And she goes into the house, and soon the laughter in the house was replaced by screams. She devoured the entire family. All right. So I guess Joanne has some issues going on with her. She should probably see a psychiatrist. All right, we'll take one of those online courses, help her control the little issue there, right? So, all right. So, good going, Joanne. All right. So here's a very, very popular question. The examiner will give you two triangles sometimes. And it looks like this triangle got slided, right? It went from, we're assuming that the red one is the original triangle, and it slid to the black triangle. Now, if you notice, the triangle hasn't changed its orientation. Like if this was its eye and this had a mouth, the eye and the mouth face in the same exact direction, right? It hasn't been rotated, it hasn't been reflected. So this is clearly a translation, the easy types of question. If they ask you what's the value of the translation, you need two values, right? You need a top value for the horizontal movement and an underneath value for the vertical movement. Let's just take one point over here. I'm going to call this point A and this A prime. If I wanted to move from A to A prime, but I'm only allowed to move horizontal or vertical. Now, it doesn't matter if I do the horizontal movement first or the vertical movement, but I always like to do the horizontal movement first. How would you move from point A to A prime? And I will move this point 1, 2, 3, 4, 5. And when I reach here, I will move up by how much? 1, 2. So the question is now, look how simple this is going to be. How much points did I move horizontally? I moved 5 points, right? So my top number will be what? 5. And how much points did I move vertical? 2. Now we just have to figure out whether it's positive or negative. The horizontal movement, I move to the right. Should this 5 be positive or should this 5 be negative? If I move horizontally right, it's supposed to be what? Positive, right? And now when I move upwards, this 2 is also positive because when you move upwards, the value is supposed to be positive. That's the end of the question. It's literally as simple as that. You take 1 point, move horizontally, and then move vertically to reach the other point, the corresponding point. And you just ask yourself, well, how much blocks did I move horizontal? Write it down. How much blocks did I move vertical? Write it down. And then ask yourself, it's what? If the signs should be what? Positive or negative. So this is the value of the translation. I'm using the letter T for translation. Okay. Screenshot this if you need to, right? But translations is going to be very easy. It's way easier than rotations and, stuff like that. Take a 10 seconds and we will move on. Red. If we go in the opposite way, let's say if the examiner told us this was the original triangle and the red one was the triangle after, won't the translation just be the opposite? It just make the signs the opposite. Won't it be -5, -2? And that would make sense because look at it. To go from A to A prime to A to reverse, you will have to go 1, 2, 3, 4, 5. You will have to move 5 to the left horizontally. So the top value becomes -5. And then once you reach here, you have to move down, keyword down, how much places? 1, 2. So since we're moving downwards vertically, it has to be -2. Right? I'm just showing you both versions of it. To move one direction and then to reverse it. By the way, vectors and this topic are related. They overlap. All right, so let's see what's going on with Joanne here, right? Clearly, right? Clearly not someone good to go camping with. So Joanne soon realized that full moon, she would transform into a werewolf and attack anyone or anything. She was unable to control it, and for over the years, she took more lives than she could remember. All right. So let's see some of her victims here. All right, so that's like a kind of animation, you see in those comics, right? So that's so Joanne is obviously gonna have to try to do something about this problem, right? I can't see her her letting this problem continue for too long. So anybody have any guess of how she's going to control this problem. How is she going to stop turning into a werewolf? Right? She's gonna have to find a solution for this, right? I don't think it had YouTube at that point in time, so she can't really watch a self-help video. All right, somebody said a magic potion. Somebody said, but the pendant, right? Maybe the pendant has something to do with it. All right, so you think you all could do this one for me? Let's say, find the vector that maps the red triangle onto the, when I say vector, it's supposed to be translation, right? You have to get two values for me. So quickly, I know you need to put your fingers on the screen, right? The red triangle is the original triangle, right? If you read the instructions, you're moving the red or you're sliding the red to the black one. Get the value of the translation for me. Gotta get the signs correct also, right? Send the answer on the chat, please. What's the translation? So we just have to take two similar points, any two similar points. I'm going to go with this, right? Does anyone go give you the same answer? So we're trying to go from here to here. 1, 2, 3, 4, 5, 6. So we move 6 to the left, right? Once we get underneath the point, we have to move up. 1, 2, 3, but we move up. So we move 6 to the left and 2 up. Remember, when you're moving to the left, the horizontal movement, right? If you move to the left, it is negative. If you move to the right, it's positive. If you move up, it's positive. And if you move down, it's negative. So it's supposed to be -6, +2. Oh, sorry, 3 up. Sorry, 3 up. No, not 2 up. Sorry, my mistake. 3 up. So it's +3. So it's -6, +3. Right? Now, some of y'all had +6, right? But I hope you see the error there now, right? So it's -6, +3. Right? So screenshot this one if you need to. It's just a simple example, right? And the questions on translations can come simple like this. Believe it or not, it can come simple like this. Right? Remember, in these questions, the horizontal movement has to go on top. It have nothing like you put the -6 underneath and the 3 on top and it's still correct. That is 100% wrong. Horizontal movement has to go on top. Vertical movement has a specific place, the underneath, nowhere else. All right. So Joanne has no choice now to try to get rid of this curse. So she visits a gypsy, right? Having tried every medical avenue to stop the transformations, no pun intended here, even though we're doing transformations, right? She visited a gypsy. The gypsy told her she could not break the curse, but instead gave her an artifact. Once she always kept it on her, she would not transform to a wolf. So Joanne needs to always keep that on her. Otherwise, she will turn into a werewolf at full moon. But the price of the relic would be steep. Her soul will never go to hell or heaven, but instead roam the graveyard for all eternity. Right? And unfortunately, if things were not bad enough for poor Joanne, the gypsy was from Trinidad, so this happened. She also blackmailed Joanne for 500 gold coins, or she would tell everybody. And this is Joanne's reaction. Ah, poor Joanne having no luck in life. I can make this joke. I'm from Trinidad, so. All right. So let's move on. Yeah, typical Trini. All right, guys. So we're almost finished with class there, right? So next week I just have to but we have another translation question, but next week I need a favor. I need for you all to bring some graph paper to class, right? You just need about 4 sheets of graph paper, not much. If you have a book, great. But just 4 sheets of graph paper, because when we're doing the past paper questions and whatnot, you're gonna have to draw it out on that end. All right? So have your rulers, graph paper, and pencils ready. So guys, well, we're almost at the end of class and we're almost at the end of translations. It's just a practice next week. So guys, I hope you all enjoyed the story of Joanne, right? Okay. And that brings us to the end of class, right? So see you guys next week, and Miss has English at 11:30. Have a good day.